Hi there, this is exercise 3A.2, another look at transformations, getting steadily harder. So 3A.1 was really just a review of what we've seen before. This is certainly an extension, so let's crack on. Starter then. Now, I did say in that last one, you're going to have to understand that there are more graphs going to be thrown your way. So to a certain extent, we're lucky in this question because it doesn't say to us, draw the picture. It just says what happens effectively when we transform. Describe the transformations, if you like, which is a bit easier, but just be aware that we're meant to know, for instance, that a cos graph looks like this going on forever and ever, and it goes actually both ways looking like that. The log graph, so this is cos x. The log graph, you're meant to know, does that, hitting there at 1, or I should have pointed out really, that goes up to 1 and it goes down to -1. And for instance, hits there at 90 degrees, 180 degrees, 270 degrees, hits the top again at 360 degrees. The second graph was log x, natural log x. I know Miss Frovine and Miss Stanley sometimes call it just ln x. The x cubed graph we saw in the last video, that's the x cubed graph, so should know what these looks like. The sine x graph, very similar to the cos graph, apart from it starts there. Instead it goes, it just keeps repeating forever and ever, and the other side does the same thing. So notice that goes 90, 180, 270, 360 back to the middle. 450, it just keeps on going up, and it goes down to -1 and up to 1. So those are the graphs. Nevertheless, what would happen if we transformed them like this? Well, I want you to just be aware. I'm going to effectively teach you this now. It's these that are the problem for you. So cos of 2x plus 1, you want to say to yourself, well, there's two things going on. There's obviously a stretch. The 2 makes it a stretch, scale factor of 1/2, and the +1 makes it translate and 1 to the left. Now, interestingly, the order for these is, well, this thing can be done at any time. I'm going to do that first simply because it's the easiest. So this is a stretch. It's parallel to the y-axis. Scale factor of 3. Now that can be done at any time. These two, though, are both in the same direction. The 2x stretches it left and right. The 1 moves it left to right. So interestingly, we do it in the opposite order to Bodmas or Bidmas, whatever you call it. So we need to learn to do the +1 bit first when we're describing it. So this is a translation. It's left and right. So I'm going to say it's a translation 1. Oh, -1, it's a +1, so it goes 1 left, -1, 0. And finally, I'm going to say the stretch, this bit here, this is parallel to the x-axis. And scale factor here is 1/2. So there's no difference really in what we've done now and what we're doing before, other than the fact there's two things in the same direction. And whenever it's in the brackets, you kind of end up doing it in the wrong order. You'd kind of think you'd do, you'd follow the rules of Bodmas, because that makes sense, but in actual fact you don't. And when we come back to lessons properly, I can show you why. So this next one, notice again there's a times at the front, so that's just this one. That's going to be number 1. I'm going to stretch it parallel to the y-axis, scale factor of 4. So that can be done at any time. I just done it first. Secondly, what else we've got? Now we've got two things in here again. So there's a times in by 3 and there's a take away 2. Interesting, I'm going to describe the take away 2 first. So I'm going to say it's a translation. It says minus, so therefore I know it goes right. And it's right by 2, 0. And thirdly, the final thing, it's a stretch parallel. Now this is in the bracket, so it's to the x-axis. And what's a scale factor? Well, it says 3, so the scale factor is a third, because it's always the wrong way round in the brackets, and that's the way I want us to think about it. Let's look at this one. Well, again, two things in the bracket, so I'll worry about that. And this one is just a translation, making it move up one. So let's start with that one, because that's got only one thing going up and down. And so you'll notice what I'm concentrating on here is, well, I've got two things in the bracket. Translation by 0, 1 up. And then secondly on this one, get a bit of room here, secondly, I can either say it's times by that or it's minus 3. I always talk about the translation first. So this is a translation 3, 0. Number 3, third thing I do is a stretch parallel to the x-axis. Scale factor, what's it says? It says a quarter, so it's scale factor of 4. Always does the wrong thing. Lastly, again, you'll notice I've got a times. I'll do that one first. Number 1 is a stretch parallel to the y-axis. Scale factor 3/2. Don't do anything to that one, it's outside the bracket. Number 2, what are we doing? We've got a choice of these two. I'm always going to do that one first. So it's a translation 90 degrees to the right. And the third thing is just my stretch again. That's parallel to the x-axis. Scale factor of 2, because it says effectively divide by 2, so I do the opposite, I times by 2. Now, all of those could be done differently, but if you do them differently, you'd get different answers and different ways of writing it. So if you just do it the way I'm suggesting, we should be able to make sense of this. So, a bit more like the same, apart from it says y equals log. Now y equals log, I've shown you that graph just now, or I've got one very similar to this, is to the base 10. If it doesn't give you a base to the logarithm, it means to the base 10. I'll write it there, but you don't need it. And it crosses there at 1. Now just think to yourself what we're going to do. It says it's going to stretch it. We've got a times by 2 there, so we're going to make it stretch times by 2. Stretch, does it ask for describe? Yeah, so it's a stretch parallel to the y-axis. Scale factor of 2. That's my first thing. Number 2, what's it doing again? We talk about the translation. It says minus 1, so it's 1 0. And thirdly, it's a stretch. And hopefully you're getting the hang of what's going on here now. It's parallel, this time it's in the bracket, so it's to the x-axis. It's 3x in the brackets, so we're going to write scale factor of a third. Now what's it say here? It says state the x-intercept. Now I've already said that hits at 1. Now this happens when y is on the 0 line, y equals 0. So if I want to find out what my new graph does, remember it's been stretched, it's been translated, it's been stretched parallel, it's probably easiest, I think, to set the 2 log 3x minus 1 equal to 0, because that's where it will hit my new graph. I'm not sure exactly what it'll look like. So move the 2 over, still effectively going to be log of 3x minus 1 equals 0. Move the log over, that becomes 3x minus 1 is 10 to the 0, and obviously 10 to the 0 is 1. Move the 1 over, I get 3x equals 2, x is 2/3. So there's my answer, and that basically goes through the possible way of doing it, and hopefully it's the same. Describe this then, what's happening here. Again, we've got 3 things going on. The 3, it's a stretch parallel, it's outside the bracket, so this stretch is stretch parallel to the y-axis. Scale factor of 3. Number 2, it is a translation. It says +1, so we know that goes 1 left instead. And thirdly, we have a stretch, and these are all the same now. Parallel is in the bracket, this 2x, so it's to the x-axis. Scale factor a half. Alright, so state the first x-intercept for the original and the transform function. Okay, so let's just go back. It says the x-intercept, So where does it hit the x-axis? So my original graph does this. This is what my sine graph does. The only problem is, obviously we're going in degrees, so that just need to know that's like 180, and that's 360. So that's my first intercept, I suppose. Oh, well, maybe, yeah. So it's going to go 1 to the left, and then, so it's normally hitting at 180. So what I'm thinking to myself, if it goes 1 to the left, I want to call that 179. The stretch parallel won't make any difference. That will just make it go higher. So that won't make any difference. And then it says x-axis scale factor of a half. So it's going to squash in. So I want to say it's 89.5. Let's say, there you go. Ah, they're talking about that being the first. All right. Well, I'm not convinced that is the first. But if we're talking that one, then it's 0. We move that one over, so that means it's -1. And if I then half it, it's -1/2. So that point will be at -1/2, 0, which is what it says. Good. I don't think we're going to get through all this. I'm going to finish off in a bit, and then I've got a couple of exam questions to show you. So I'll label it up as exam questions, and then you'll do the exercise. So in total, I think there's going to be 3 videos here. Describe fully this transformation. So I've got y equals cos of x minus x over 2 minus 2 plus 2. Now, I haven't got a times at the front here, but I have got a +2, so I might as well get rid of that straight away. We've got a translation. You'll notice this is outside the bracket. And the translation is +2, so that's 0.2. So that's the first one. And now notice we've got 2 things in the bracket, and they both go the same way, so we just do the same thing as we always do. I'm now going to say it's a translation, because we always do the translation bit first, and that's -2, so that's 2 0. Now I could have combined those as it happened, just said it goes 2 across 2 up. Anyway, the third thing that happens then is it's a stretch, and it's parallel to the, well, it's inside the bracket, so it's to the x-axis. Scale factor, well, it says divide by 2 in here, so it's scale factor times by 2. And I think that's what it wanted on that one. Yep, there you go. So these are, I've got some questions for you here. It might be worth me saving these, so anyone who wants to have a look at these, I'm going to go through them properly in a bit on a third PowerPoint. But for now, you're welcome to have a look at some of these, but just be aware that some of the later ones you might need to look at this again. So exercise 3A, questions 4 to the end, but do please check the third and final extension on this third lesson video, and I'll go through those 3 exam questions. Okay, so good luck, and see you in a bit.